Hello viewers, you are welcome to this video. Today I want us to look at what a function is. What is a function? Viewers, a function is any relation between two sets, x and y, say x and y, in which each member of the set x is related to one and only one member of the set y. Again, a function is a relation between two sets, say x and y, in which each member of the set x is related to one and only one member of the set y. Okay, so let's look at this. When you have something like this, so let's call the first set x, the second set y, and this is the function. So you see that this is a function f from set x to set y. Are you seeing it? So you can write it this way. So you can say f s minus 1 to y. This is a function. Are you seeing it this way? Okay. Now, and then let me write these values. You can have say m, n, p. This is mapping onto this, mapping onto this, this mapping onto this. Okay, you have something like this. Viewers, this is a function. What you are saying is that every member of the set X should be related to one and only one member of the set Y. Are you saying? So let's look at it. A is related to M. B is related to N, C is related to N, D is related to P. So this is a function. Now let's look at another one. Let's look at another one like this. You can have something like this. Let's call this one a function G. And so you can say G, and this is the function. Okay. Now, if you have, let's say 1, 2, 3, 4, and then this one can be say 8, 9, 10. Yes, viewers. This is also a function because this is related to only one member here. This is also related to this, 4 is related to 11. So this is also a function. Now viewers, look on the board. If I do this, as soon as I do this, same example, if I do this, and this 4 ceases to have an image here, or ceases to be related to an element or member here, then this is not a function. This is not a function. What you are saying is that when you are here, you should have at most one image. But you cannot say that I'm here and I don't have. So normally to understand functions, you normally say that the first set can be referred to as female, the second set male. Viewers, let me use this one to explain to you. You see, we are saying that every member here should be related to one and only one member of the second set. Every member of the first set X should be related to one and only one member of the second set. What this means is that there is no way that you see a female who is married to 2 or more men. You can't have that. The word is married. Yes, you can't have a female who is staying with 2 husbands. It's not acceptable. Yes. So if you are here, you should have 1. So look at it. So A has 1. A female A has 1 husband M. Female B has 1 husband N. And female C has 1 husband N. So you see, a man can marry 2, 3, 4, whatever. But a female cannot do that. Do you see? So you can see that here, this n is related to B and C. It's a function. It's a function. Yes, because I have been seeing that. You can see a man who is married to 2, married to 3, married to 4, married to whatever number the person wants. Do you see it? Yes. Now, this D is marked to this. Now let's move on to this one. Here, we are saying that this is not a function. When there was a number here, and this was marked and related to this, we said that it was a function. This female has 1 husband. This female, 1 husband, 1 husband, 1 husband. I want you to understand, that's why I'm using this to explain to you. But as soon as I break this one, this way, because there's a female here who doesn't have a husband, this is not a function. Now let's look at more examples. Yes, let's look at more examples. You can have something like this. Let me clean this one. So I'm going to draw some things and ask you to tell me whether they are functions or not. When you have something like this, A, B, C. Then this one, let me say D, E, F. This is marked onto this. Isn't it? Now, this is marked onto this. This is marked onto this. And this is marked onto this. Wait, let's look at what is happening here. A is related to D and E. So, a female A is married to D and E. This is not possible. Yes. Are you seeing it? B is married to E. Okay. And you can see that this E is married to A and then B. It's allowed. But because a female here, A, is married to 2, it's not allowed. So this is not a function. This one is not a function. Are you seeing it? This one is not a function. So what this means is that for a relation to be a function, it should be 1 to 1. Yes, it should be 1 to 1 or many to 1. But you cannot have 1 to many. No. And the point they're also making is that every element in the first set should be related to one and only one member of the second set. And every member of the first set should have an image. Yes, should have an image. Yes. Okay, now let's look at another one let's look at another one. You can also have something like this. I want you to understand, that's what I'm giving you all this. I can also have something like this. Maybe L, Q, N. You can also have something like this. And then have G, U, W. This is marked onto this. This is marked onto this. And this is marked onto this. Viewers, this is a function. So this is X. Let's put this one is Y. So we can call this function maybe H. Okay? So H is such that X marks onto Y. Viewers, this is a function because R is related to D. Yes, R has 1 husband. Q also has 1 husband. N has 1 husband. Yes, there is a man here who doesn't have a wife. That you don't care about that man. Do you see it? You don't care. That does not bother us. We are not bothered by that. Do you see it? Yes, we are not perturbed by this one. No. Do you see it? So we are only interested in the female. The female should have 1. Everybody should have 1. Do you see it? Yes. But 2 females can be married to 1 husband. Yes. 3 females can be married to 1 husband. So this is a function. Okay. So I believe in these examples, when we have a relation, you can tell us whether it's a function or not. Now, normally, you call the first set the domain. The first set is known as the domain. And the second set, so when you have something like this, let a function this way, then the first set is the domain, and this one is known as the codomain. Codomain. Yes, codomain. Now, we also have what we call range. Now the range is a set of all possible images of the elements of the domain. Yes, all the possible images of the members or elements of the domain. Isn't it? So when I give you something like this, when you have a function like this, A, B, C, D, then this is marked onto say M, this is marked onto N, this is marked onto K, isn't it? And then this, let me write R here, and this is marked onto this. This is a function, and we are saying that the domain will be A, B, C, D, and then the codomain will be M, N, Q, R. That's the second set. Now the range is a set of all possible images of the members of the first set of the domain. So the images here, you see that this one is not related to anything. So the images here will be M, N, Q. So the range will be this. So this will be the range. So you can see that here, you can say that the domain, that is the set X, is equal to A, B, C, D. Isn't it? This is the domain. And then the codomain is the Y. This one. Isn't it? So let's call this one as the function. The codomain is M, N, Q, R. Now the range will be M, N, Q. Isn't it? The set of all possible images of the elements or members of the domain. This is it? So M and Q. These are the images of the elements here. Yes. Now at times the range will be the same as the codomain. For example, same example. If I do this, isn't it? If I do this, then because now R is related to a member or element in the domain, the range will now change to M and Q R. And you can see that if that happens, then the codomain and the range will be the same. Do you see it? So at times the range and the codomain are the same. Yes, at times they are the same. Okay. Now, let's also look at this. You can give me something like a functional notation. You can give me something like this. If F is such that S maps onto, say, S squared plus 4x minus 2, isn't it? You can ask you to find, you can say find I, F of 2, I, F of negative 1, I, F of say A, IV, F of 1/2, isn't it? And then, okay, so let's look at this. So we have been given this. So when we have this, is the same as this F of x equal to x squared plus 4x minus 2 US. So if you have been asked to find F of 2, what this means is that wherever you see x, are you seeing? So F of x is this. So when you're asked to find F of 2, it means that wherever you see x, you should write 2 there. So I've seen x here, I'll write 2, so 2 squared plus 4. I've seen x, then I write 2 minus 2. And this one will be equal to 2 squared is 4 plus 8, that will be 12 minus 2, 10. Are you seeing it? Now here, F of negative 1, it means that wherever you see x, write negative 1. So this one will be negative 1 squared, because I've seen x, plus 4 times negative 1 minus 2. Negative 1 squared is 1. Are you seeing it? Minus 4 will be negative 3. minus 2, negative 5. So f of negative 1 will be negative 5. Now let's look at this one. F of a. You have been given f of s to be this, and they are saying find f of a. What this simply means is that wherever you see s, write a. Isn't it? Wherever you see s, write a. So s is equal to a. So I've seen s, so I write a squared. Isn't it? I've seen s, so it was s squared, so a squared. Plus 4, I've seen s. You are saying I should write a minus 2. So if it is f of k, wherever you see s, write k. Isn't it? So it's not equal at all. So this will be f of a. Now f of 1 over 2, wherever you see s, write 1 over 2. So this one 1 over 2 squared plus 4 times 1 over 2 minus 2. This one 1 over 2 squared will be 1 over 4 plus, then this one will be 2 minus 2. Isn't it? And this one will be 1 over 4. So it is not difficult at all. This is functional notation. Yes. Viewers, at times you can also give you this, something like this. You can say that if, okay, let me clear this one and look at that one. You can say that if f of x is equal to x, find I f of negative 4. I f of 5. Viewers, you see f of x is equal to x. When it happens like we call this one identity function. F of x is equal to x. So what this simply means is that wherever you see x, write negative 4. So f of negative 4 will be negative 4. You say x, x. So negative 4, negative 4. F of 5 will also be 5. So you say f of 1000 to be 1000. So we call this one identity function. Okay. You can also give you something like this. You can say if f of x is equal to say 2, find f of, that is I, find f of negative 6. I f of 3000. Isn't it? Now you guys look on the board. F of x is equal to 2. You see that 2 is a constant. So when you have something like this, you call it a constant function. Now, what this means is that this will never change. Let's look on the board. You see, you have f of x equal to 2. So we have to find f of negative 6. On the functional notations you have been doing, it means that whenever you see x, write what? Negative 6. So I'm going to write this one. This is what I've been given. I've written 2. They are saying whenever I see x, I should write negative 6. I've not seen any x here. So the answer is 2. Now f of 1000. F of 1000, that whenever you see x, write 1000. So I'll go here and then write 2. I'm looking for x. I can't see x anywhere, so the answer is 2. So it can give you something like this and ask you to find this, and try to confuse you. So you have to be very, very careful because there is no s attached to this. So this is a constant function. So no matter the value here, the answer will remain the same. So you can say if f of x is equal to negative 6, find f of negative 10. You just want to confuse you because there is no s attached to this. The answer will be negative 6. F of negative 5000 will still be negative 6 because there is no s attached to this. You place s with the value here, but there is no s attached to it. So we call these constant functions. Okay. Now viewers, let's quickly look at this and bring this lecture to an end. Yes. At times we can give you a graph and ask you to tell us whether it is a function or not. Yes. Is this graph a function? Okay, so let's look at it. Let's look at something like this. If you have a graph this way, you have this graph. Yes. This is x. If you have a graph this way, is this a function? This one, is this a function? Yes, we can ask you, is this a function? If it is a function, you tell her. If it's not a function, you tell her. Now, viewers, look on the board. You see that I've told you that a function is any relation between two sets x and y, in which each member of the set x is related to one and only one member of the set y. Yes, and I also use the female male to explain to you. And you said that if you're a female, you should be related to only one man. You all should be married to only one man. Now, what this means is that this is the first set. This is the male. So, what this means is that when you are given any function or any graph to check whether it's a function or not, what we are going to do is that we are going to draw a vertical line to pass through any part of the curve. If you're able to draw a vertical line and the line casts the curve at only one point, then it's a function. You can draw any vertical line at all. Yes, if you do that and all the lines are cutting the curve at only one point, then it means that it's a function. Yes, that is, if each of the lines, the vertical lines you are going to draw, cast the given curve at only one point, then it's a function. Otherwise, it's not a function. When you cast the given curve at only one point, it means that every member of the set X is related to one and only one member of the set Y. So let's look at this graph. If you try to draw a vertical line, look at it. It has cut this at this point. Any vertical line at all you draw, it will cut the curve at only one point. So this graph is a function. So this is a function. Now let's look at another example. You can also have something like this. You can also have something like this. Something like this. Is this a function? This one. Is this a function? Yes. So if you draw a vertical line, look at it. It's cutting the curve at one point. In each of these vertical lines is cutting the curve at only one point. So this is also a function. Yes, let's look at other examples. When you have something like this, viewers, let's look at something like this. Let's look at a graph like this. This is x, this is f, this is, let me call this one y. Now when you have this, if you decide to draw a vertical line this way, you see that it has cut the curve at 2 points. Look at this one. If you only get one is enough. You're able to get one line which is cutting the curve at more than 1 point is enough to say that this is not a function. So this is not a function. Okay, let's look at other examples. You can have something like this. You can have something like this. And draw something like this. This is x. This is y. Viewers, clearly you can see that this is also not a function, because when I draw this, it has cut the curve at 2 points. Here too, it has cut, look at it, 1, 2, 3. So this is even enough to see that this is not a function. This is not a function. Now let's look at the last one and bring this lecture to an end. When you have something like this, something like this. Yes, viewers, this one is a function, because if we draw any vertical line, it will cut the curve at only 1 point. So, thank you very much for your attention. For more of this video, subscribe to my YouTube channel, Shamalaa Jnr, if you have not done so.